Hi guys, welcome back from the ad break. So now we are on our last segment for the show. We are going to look at now a few questions to try and solve them and then see how do we then draw them graphically. But remember, I will keep on saying the graphical part of it is just me trying to show you how do you then visualize this thing. You don't necessarily need to then draw the graphs. No, what you need to do is to follow the steps that I gave you in order to solve all of these questions. So let's have a look at our first example for the last segment. So remember, just before that, the types of equations that we've spoken about so far will be the linear, quadratic, and the hyperbolic. The cubic and the exponential, I said, just don't look at them as yet. Now, the types of simultaneous equations, there is where one point of intersection is there. That's when we have a linear and a linear. And then there is 2 points of intersection. That's when it's a linear and a hyperbola, or a linear and a quadratic, right? So those are just L's, guys. I know they look very weird, but it's L. And then the question will always be solve for X and Y simultaneously. Remember my steps, guys. Please remember them at all times. You always label them equation 1, equation 2. Then you will say from equation 1, I create equation 2. So my equation 3, which will be X plus 5. And I will label this equation number 3. And then the beauty of it comes in when you then say to me, no, let's then substitute equation 3 into the equation that we did not use, which is equation 2. If you substitute this into equation 1, I promise you, you're going to get 0 is equals to 0, which will defeat the purpose of what you're trying to do. So just don't even attempt that. Now, I'm just going to rewrite it this side. So remember, my equation 3 was y is equals to x plus 5. And I'm now on the step where I need to substitute this. So wherever I see y, I'm going to replace it by x plus 5. So this will be x plus 5 minus x squared equal to negative 3x plus 5, and then you simplify, write it in standard form. It becomes minus x squared. The 3x will then become 4x. The 5 and the 5 will then be 0, and this will be equal to 0 there, right? Then I will divide everything by negative because I can't deal with the x squared being negative. So it becomes x squared minus 4x equal to 0. Take out a common factor, it becomes x minus 4 in the bracket. Then my two solutions will be x is equals to 0 or x is equals to positive 4. Now remember, from here, you need to sub the x values, right, into x values into, I'm just going to use equation 3 because already it has y as the subject of the formula. So for x as equal to 0, I will have y as equals to 0 plus 5, which is equals to 5. And then for x equals to 4, I will have y as equals to 4 plus 5, which is then 9, right? So my last thing that I will do is, remember my two pairs are 0 and 5, 4 and 9. 0 and 5 and 4 and 9, or 4 and 9, right? So remember to always just try by all means to maintain writing them as an ordered pair. Graphically, this is how it will look like. So my 4 and 9 will be there, my 0 and 5 will be there. So this is where I have two intersections, right? This is where I have two intersections at 0 and 5, and at 4 and 9. But remember, this is just an additional thing that I'm doing for you guys to understand everything. Solve for x and y simultaneously again. Here I have a linear, which is equation 1, and I have a hyperbolic, which is equation 2. I know when we started with this, I kind of added some spice there and I used the hyperbolic, but with this I'll just use the linear, right? So it will then give me x is equals to, or rather let's just make x the subject of the formula. So it means the y must go that side. So it becomes 4 plus y. Now maybe let me just show you what I mean. So it's 4 plus y equal to x. I'm just writing it in standard form, right? And then this was from equation 1, remember that. And then I label it equation number 3. Then from there you will then substitute. So equation 3, we just agreed it's x is equals to 4 plus y, or y plus x, it doesn't really matter. If I substitute this, I will have y into 4 plus y equal to 12. And then I solve for y, which will then give me 4y plus y squared minus 12 equal to 0. You write it in standard form, it's y squared plus 4y minus 12 equal to 0, and then you will need to simplify this, which will be y plus 6 and y minus 2 equal to 0. My y will be equal to negative 6, or my y will be equal to positive 2. And then remember that instruction there, right? I don't really have enough space here, but please remember the instruction about substituting, right? About substituting there. And then wherever y is equal to negative 6, it will then make x to be equals to 4 minus 6, which is minus 2. Whenever y is equals to positive 2, it will make x to be equals to 4 plus 2, which is equals to positive 6. And then the last thing I will always do for you is to write this as an ordered pair, which will be minus 6 and minus 2 and 2 and 6, or 2 and 6. Graphically, it will then look something like this. I will have my negative 2 and negative 6 there. So my x value, let me see something. Oh yes, I rewrote the pairs incorrectly there. So I was now confusing myself because I started with the y's. Right, so you can see the typical mistakes that we make. So this is negative 2 and negative 6, and this is 6 and 2. So on the graph, it will then look something like this. It will be in that quadrant. That's the first intersection. Really, negative 2 is somewhere there, and 6 will be somewhere there. And then with this one, 6 will be somewhere there, and positive 2 will be somewhere there. And then you can then see exactly where these two graphs are intersecting. But this is just an extra. You don't necessarily need to draw this, please. Another question now. This looks a bit complex, right? But it's really not complex. Firstly, I will quickly label them. The very first thing, as soon as you get these equations, just go straight to labeling them so that you can see what you are trying to do. Now, I will take one of the equations. So you can see, if I take equation 2, I can make y the subject of the formula there, right? Similarly with equation 1, I can make y the subject of the formula. Why am I only talking about y? Because as soon as I try to make x the subject of the formula, I will then have either a fraction or a square root that really is going to be messy for me to work with. So I will say from equation 1, I will have negative y equals to positive 4x minus 6. Then y must always be positive, which is minus 4x plus 6. And then this is then my equation 3, which I'm just going to write here for you. Y is equals to negative 4x plus 6. And then remember, the instruction is to sub 3 into the one that you did not use. Please remember, it's you subbing whatever that you just created into the one that you did not even touch. Because if you substitute it into the first equation, it will give you 0 is equals to 0, which will defeat the purpose of what you're trying to do. So this will be 12 minus 2x squared minus, I made y the subject of the formula, so it will be minus 4x plus 6, and this will be equal to 0. Then I solve for x. It will then give me negative 2x. Let me just rewrite this properly. 2x squared, and this will give me 4x, so it's plus 4x. It will be negative 6, and the 12 there, which will give me plus 6 equal to 0. Then you see that I can divide everything by negative 2 instead of just a negative, which will give me x squared minus 2x minus 3 equal to 0. You factorize this, it's x minus 3 into x plus 2 plus 1. X plus 1 there equal to 0. Then my x will be equal to 3, or my x will be equal to negative 1. For the y value, the first one, if I multiply by 3, there is negative 12 plus 6, which will give me y is equal to negative 6. Then here it will be y is equals to a positive 10, if you substitute those. And then I'm just going to write these in pairs, right, quickly for you. It's 3 and negative 6, 3 and negative 6, and, or minus 1 and 10. Let me just verify, yes. Now, just to summarize everything that we've looked at, please remember to revise the meaning of the word simultaneous. Practice solving different combinations, please, by using mainly the substitution. And then remember, the solution of a simultaneous equations are points of intersection of graphs, although you don't really need to draw these graphs. But it is important for you to just remember that, because at a later stage when you're looking at functions, it will then come in handy for you. Guys, I hope you had fun, because I definitely did. And until next time, I hope you will be able to practice and investigate all the things that you did not understand. Remember, mathematics is food for the soul. From me, until I see you next time, stay safe.